Okay. So factor label is the first part of the test, 4 factor label problems. And the next part is chapter 3, which has a great deal to do with vocabulary words, doesn't it? Not just, I'm going to ask you to say, write out the definition. I'm not going to do that. I almost never do that. But if you know the definition of a solution, what if I ask you right now, what's the difference between a compound and a mixture? All right, who wants to do that one? What's the difference between a compound and a mixture? Ethan looks like you're very eager. All right, Ethan, what's the difference between a compound and a mixture?
A compound has like pure substances, and a mixture there's like heterogeneous and homogeneous mixtures. That's about all.
All right, now, thank you for doing that, Ethan. If you thought you couldn't even have done as much as he did, you're in a little bit of trouble. If you thought you could do more than he did, then you're maybe not as much in trouble. But did you like what he said? He said compounds contain pure substances. What do you think about that? What do you think about that? I thought compounds were a pure substance. I thought there were 2 things that were classified as pure substances. What are they? Elements and compounds. So they don't contain pure substances. Can mixtures contain pure substances? Yes. But are mixtures pure substances? No. You see how you do that? That's how you have to ask yourself that question. What's the difference? What's the difference between an element and a compound? Matt, you do it.
An element is just a single type of atom.
Yes.
And then compounds like 2 or more.
And are they just mixed together?
No, they're chemically bonded.
Yes, they're not mixed. They're chemically bonded together. Everybody get that? All right, let's go with, I don't know, Maddie. You ready? What's the difference between a heterogeneous mixture and a homogeneous mixture? A little bit louder. I couldn't hear everything, but did you say heterogeneous mixtures are what? Are made up of more than one thing? And what about homogeneous mixtures? Are they made up of more than one thing? If I gave you some salt water, what would it be made up of? Salt and water. So are homogeneous mixtures made up of more than one thing? Yes. So we got to watch our words, don't we? Heterogeneous mixtures and homogeneous mixtures has to do with when I look at you. If I look at you and I see more than one material, then I call you heterogeneous. Is that right? But if I know I mix 2 things and it looks like I only have one thing, then that's a homogeneous mixture. All right, Caroline, what word do you use to describe a homogeneous mixture? Solutions. Everybody get that? A solution, the mixture is so even throughout that it is dissolved. We say one material is actually dissolved in another. So they're not chemically bound together. All mixtures can be separated by what? Let's go with Lacey. All mixtures can be separated by Can I separate a mixture by using physical means, or do I need a chemical reaction to separate them? Okay, now heterogeneous and homogeneous, they do have something in common. They're both mixtures, aren't they? And all mixtures can be separated by doing what? What kind of, do I need a chemical, by chemical means or by physical means? Do you understand what I'm doing right now? You say you know these words, but maybe you're playing some game and saying, he's not having me do a matching. Match the definition. I'm not doing that. You got that? if you know the word, you'll be able to answer the question. If I want to separate H from O in water, can I do that by using ordinary physical means, or do I have to have a chemical reaction take place? I do. The only way to separate the things that are in a compound is to use chemistry. You have to have a chemical reaction take place. But all mixtures can be separated by not chemical reactions, just physical means. You get that? And so that's kind of important. And so some of the drawings in your book, and I'm going to do some demonstrations today, and I hope this makes sense to you. So I think I'll start out with the first one. If you look at where look at Elizabeth. Doesn't she look nice? Okay. Now, if you would either back up just a little bit, Elizabeth. There we go. Now, a student made this a few years ago. It was an extra credit project. This is one of the drawings that you drew, and it has the name electrolysis. Okay. Lysis means to split or destroy. To split or destroy. To split or destroy by using electricity. That's why it's called electrolysis. Is that? And I could have asked the school for about a $150 apparatus that I would use once a year. I could have. I don't like to do that. I don't like to waste your money. Your parents come here. I actually do have a small kit. I had 2 people last year. Not this week. Busy week this week. But they came the week after, and they said, I want to do an extra credit experiment, and I'll do electrolysis. And the only thing I ask you to do is bring your own 9-volt battery. And if you like doing that kind of thing, come and see me next week, okay? It probably take you about an hour. It takes about an hour to do it, and but anyway, if you feel like doing it. So if we hook up electricity to water, we notice that gases appear. Now, I didn't start with any gases, did I? Well, that's kind of evidence. There's many things that are evidence that a chemical change took place. One of them is the formation of a gas. And I didn't start with gas, but I have a gas here. I also noticed that the amount of gas here is less than this. This amount of gas is more than that. Matter of fact, it's about twice as much. The theory is that if you take water and let it undergo electrolysis, it will split the water and cause hydrogen gas and oxygen gas. And this is the oxygen gas, and this is hydrogen. How did I know that? How did I know that this was where the hydrogen gas was?
There's more hydrogen.
Wait a minute, hang on.
Because there's 2 atoms of hydrogen in water.
That's right. H2O means for every 2, there are twice as many hydrogen atoms as there are oxygen atoms. You get that? And so that's a great, is that a chemical change or a physical change? We got to come up a little faster. It has to be chemical because was there a new chemical produced, or do I still have just water? No, I have new chemical, oxygen gas and hydrogen gas. And by the way, the only way to separate elements in a compound is what? Physical means or chemical? This has to be a chemical reaction like that. I'm going to do this demonstration here in just a minute. There's another drawing you guys did. Here, they put some sand and, I don't know, sand and maybe salt and water. They put it together. Okay, they have a funnel, and I'll make one of these for you. Filter paper, you pour it in there, and the water goes through the filter paper, but the sand and the salt, the salt was dissolved, my fault. The salt was dissolved in the water, the salt water comes through, and the sand gets trapped. Now, did I separate things there? Did I separate the sand from the salt water? Yes, because the salt water went through the filter. The sand was not able to go through the filter, was it? I separated sand from salt water. What kind of a change was that? Physical change or chemical change? Physical. And that's right, you can separate a mixture by physical means. Is this coming together at all? Let's say I had some salt water here. Now I want to separate the salt from the water. What if I want to separate the salt from the water? So let me start this up. Excuse me. All right. what if I wanted to separate salt from water? All right, what do you call this apparatus here? Is called a filtration apparatus, and I'll make one of those, and you guys will do that in your next lab you do. And then here's something here. What is this called? Who remembers that? Let's see. Ty, what do you think? What do you call this kind of a setup? Can you see it? Yes, distillation. You get that? Now, if you have two things that are mixed, let's say there's a solid and a liquid that are mixed and they dissolve. If I were to boil salt water, what would come up here? Would I get salt water steam? I used to think that. I thought, well, the steam would have to be salty, but what's the only thing that's going to change from a liquid to a gas? Not the salt, just the water. And so by boiling the water and then condensing it, and it comes down here, I would eventually separate salt from water. Now, is that a physical means or a chemical means? Is that a chemical reaction or is it a physical change? What do you think? Physical? How many people say physical? You're correct. Okay, that's a lot of hands. See, there was no chemistry there. There was no chemical reaction. And by the way, I just said if you want to separate things from a mixture, you don't need chemistry. You don't need a chemical reaction. That's all. This is filter. All this is physical change, okay? All right, I'll do that in a minute. I have another one here. Now, I cannot guarantee it's going to work. I made a mistake. I was supposed to go to the store and buy a brand new 9-volt battery. All right, I forgot. And I teach every class this period, so it's today. So I had to go next door, and Miss West had a bag full of batteries. Now, I do not know if they work. So if I pick the right battery, I'll let you know, okay? If I pick a battery that still has a lot of stuff in it, good electricity, then it'll work. If not, I'm sorry, I'll try another one. What I'm going to do is I have some water here, and I'm going to put a battery in it. And just like if I were to take a paper clip and connect these two, it would get very, very hot because the electricity would actually flow from negative to positive. It would go through that wire and make that wire very, very hot. That's why you have to be careful about that. All right? If you ever get caught in the wilderness and you have a little bit of steel wool, you know what steel wool is? Like a Brillo pad, you know what steel wool? Oh, it looks like wool, but it's steel. Have you ever done that? You clean pans with, okay, you know what Brillo pads are? SOS? Okay. You can actually go to a hardware store and buy just steel wool. It has no soap in it or anything like that. If you have a bunch of steel wool, which looks like hair, it says made of wire, and you have a 9-volt with you, you just press that into the steel wool, and you'll get, they're so thin that the electricity runs through there, and you could actually put it in some leaves, touch it like there, you'll have a fire. That's how hot it gets. So, anyway, so what I'm going to do is put this in there, and instead of having a wire go from here to conduct electricity, I put a tiny bit of salt in here. Now, the only reason I need the salt is salt water will conduct electricity, plain water will not. So I need something to help me conduct electricity. They don't tell you that in the book. Okay? That's a little trick. There's another thing I'm going to do. If I put this in there and things happen, electrolysis happens, I should get bubbles. And I'll get one kind of bubble appear at one of the terminals and another kind of a gas appear here. Now, how will you know that those aren't the same kind of gas? What I like to do is, I'm going to put a little buddy of mine. You don't know this guy, but you know BTB, you know litmus, you know pH paper, but you've never met him. This guy is called phenolphthalein. Now, phenolphthalein is an indicator, and it's going to indicate if something is going on, okay? It all depends on what it is I want to indicate. So I'm going to put a little bit in there, and I'm going to mention to you again, I am sorry I didn't go to the store and buy a brand new 9-volt battery. So, what do you think? Is it going to work? Let's try it. I'm going to put this in there. Could you hit that bank of lights right there, please? The first one. Yeah, and I'll make it a little bit darker. All right, here we go. And I'm going to magnify on the camera right where the electrodes are. Come on, babe. Okay, ready? Be a good one. Ah! Oh, I made that up. You are never going to get shocked with a 9-volt battery in there, but did I get you on that one? All right, here we go. Do you see any kind of a gas being produced? Now, it seems like I'm getting a little more gas on the left side. Is that correct? And I also noticed that things are turning kind of a little more purple on the left side. Is that correct? So I am getting some gas on the other side, but not as much. I'm getting a little bubble over here, but I'm getting a lot of bubbles here. So I'm actually splitting water. I'm actually splitting water into hydrogen gas and oxygen gas. And the phenolphthalein is telling me that there's something going over here that's not going on over here. And that's kind of telling me that the gases must be a little bit different. All right. Anyway, that's called electrolysis. It's a fast way to do that. You could actually do this at home. If you had a brand new one. And by the way, I'm not going to get shocked with a 9-volt battery. Okay, did I get that? Okay. That's fun to do that, though. All right. Electrolysis. Now, let's do another one. Let's do another one. All right. You stay right there. Get this out of the way. Did I do the burning piece of paper yesterday? Okay, good. Oh, yeah, I did. Yeah. I'm going to walk right in some way. That's not going to work. Move this way just a little bit. All right. It just so happens that I had to set this up over here at the table. And all right, so you might have to duck a little bit. All right, over here, I have, here's a beaker. And let me get another beaker. So I have here some sand and some little things from an aquarium. There's some sand, okay? And then what I'll do is put some salt in there. Everybody see that? What do you call that? What do you call it so far? Hey, a really good word. I just made a what? Say it real loud. It's not only a mixture, it's a, yeah, I can actually still see the white pieces of sand, salt, right? And then what I do is, I'll put some pieces of iron. These are called iron filings because they're really tiny. They get like a file with shave it off. What do I have now? It's still a heterogeneous mixture. And then what about now? What about now? It's still a heterogeneous mixture. I can see the water, and I can see other things that are not water, all right? Anyway, oops. Okay. Well, anyway, what I'm going to do is I want to separate these. And how do you separate things in a mixture? You use physical means. And so we're going to use a thing called filtration. And you guys will be doing a lab where you built your own filtration apparatus and all that kind of stuff. I take some filter paper, right? Make a taco, and then you, this is the hard part. You have to be smarter than the filter paper. See this? That doesn't work. That does not work. Okay, so I peel off one layer, just one layer. And now it'll work. All right, here we go. I started with sand, salt, iron filings, and water. All right, did I separate anybody from anybody else? All right, what do you think? Yeah, what came out here? Do you see any salt though? Do you think there's salt down there? of those materials, one of the three, of the four materials, one of the other three will dissolve in water. Which one dissolves in water? Salt. So when I did that, the salt dissolved in the water. Now, will the filter stop the salt from going through? And it will not, because it's dissolved in the water. So this right here, I'm not gonna taste it. If I were, it would taste salty. This is salt water, and this is iron filings and sand. So how can I get that out? How can I separate the sand from the iron filings? Somebody said it. Right. Oh, I know. Paper towel. Oh, no paper towel. Okay. So I have magnets here. It just so happens that iron filing has the physical characteristics, the physical properties of being magnetized. They can be magnetized, right? So what I could do is I could reach in here. Can you see it? Now it just so happens a little bit of sand came with it because I think the iron filings kind of traps some of the sand. But I could use the physical property of iron being magnetic to separate it from sand, couldn't I? All right, there's that. But now I have another problem. I need to separate the sand, the salt from the water. Okay, how do we do that? And who did I not call on yet? Caroline. How do I separate the salt from the water?
That's like vaporized.
Say it again.
That's like vapor.
One more time.
It has to become a gas.
What?
It has to be a gas.
Can you hear her? A gas? Oh, okay. Sorry. I could do that. Do you mean boil the water? I could do that. And if I could just sit this and boil the water, only the water would leave the beaker, and what would be left in the beaker? So if you were to go home and try this, you could make some salt water or sugar water and put it on the stove and then start boiling it. And please watch it, especially if it's sugar. But watch it carefully. And as long as you don't have spattering, you should be able to make the water leave the pan and the other stuff will stay there. Let's say you made some Kool-Aid, red Kool-Aid, sweet red Kool-Aid. What if you boil Kool-Aid and keep boiling? You think everything's going to be gone out of that pan? I used to think that. But I never did see any pink clouds. I didn't see any pink steam. So what would happen if I boil Kool-Aid? The water will leave, and the sugar and the Kool-Aid powder will still be left there. And if you pour water back in that pan after it's gone, you can make Kool-Aid again. All right, does that make sense? All right, so what I'll do one more demonstration. I think I'm going to start demonstrations. I had to do a lot more of it. This one is, here I am. Where's the big, there it is. All right, Todd. We'll have you, you're gonna help me with that. Okay. So why don't you bring that card out right about here. Just nobody saw that. Here it goes.
Bears.
Alright, you're gonna put these on. Here's my lighter. There you go. Ethan. Why don't you take that, the iPad is meant to be showing this way. Okay, I don't want you to switch it because they'll turn my video off. So unplug the iPad and bring it all over here and just face the screen toward this demonstration, okay? Alright, there you go. Pick it up. Now, see if you see yourself. Do you see yourself? So when you come over here, why don't you go ahead and pull your seat right there so you can have a nice seat. So what I'm going to ask you to do is, you're going to sit down low. I don't want you up too high, so get your seat. Get your chair right here.
Worm side view.
All right.
So it's like if I hold it like this.
Yeah, you can show the whole class if you want.
You said birds.
But the main thing you wanna do is, there you go, you wanna make sure you have a good view of this right here. Now what we're gonna do is, I'm gonna do a lot of changes. We're gonna have a lot of changes take place, and, here's how it works. I have this stuff called alcohol, and this happens to be called methanol, which is, one of the simplest alcohols you can have. And so you're gonna help me with this. And what I'm gonna do is I'm gonna put a little bit of alcohol in there. Now that's plenty. I'm gonna move the alcohol over to here. Then what I'm gonna do is I'm gonna start shaking it. Now what I want you to do is, can you practice lighting that? Okay, good. Okay, now here's what I do. When I get done here, you're gonna like this, but it's very, very important that you do not ever put any part of your hand above this. You get that? So can you just practice right here? And even if you have to go like this a little bit, see that? But don't ever reach over that. Okay. So I have some alcohol in here. You see the liquid? Everybody see it? So let's go ahead and I'm gonna spin it around. Put my hand over here. What am I doing? What do you think's happening to the alcohol? What's that word? I mean, I spread it out, but eventually you'll see less and less liquid. So what's happening to the alcohol? It's vaporizing. Now, I'm doing this, so not only do I have vaporized alcohol, I'm doing something else because there was something in this before the alcohol. What was in here before the alcohol? Air. So what am I doing now? What do I do when you take alcohol vapor, and what am I doing? Mixing it with what? Air. And the main part of air that I'd like to have it mixed with is oxygen. There's only about 20% of this. See that? So now we're about ready to do that. Now what kind of a change has this been so far? Alcohol changing to, alcohol liquid changing to alcohol vapor. What kind of change is that? Physical. All right, what about the alcohol vapor mixing with air? Physical. Are you ready? All right, let's see what happens now. All of this has been physical change. All right, go ahead. That's it. Now, in that case, we actually saw a burning taking place, right? And that's always what kind of a change. And sometimes when changes take place, they do not have a difference in temperature, but I'm gonna pass this around. You won't be able to hold it very long. Ready? Catch. Pass it on.
Nice.
Pass it on. Pass it on. And what do you feel? What do you feel?
I'm a good cameraman.
It's
No, don't flip it. Don't flip it. All right, here we go. All right, here, back to me now. Back to me. Okay.
Clip it.
Now, what happened here, you'll find out later in one of our chapters,